Hello students, today I am discussing a topic of radiations named solid angle. So solid angle basically it's an geometrical shape, it's an angle, okay, and this is a three-dimensional angle, solid angle. So before explaining three-dimensional this solid angle, we want to learn what is two-dimensional angles. We know suppose we have take a pizza and some amount of part if I want to quantify, then for considering we want to considering these 2 points which are connected with the centers and makes with an arc. So the length divided by this arc is makes an angle called theta, and the unit is radian. Okay, for two-dimensional case, any geometry two-dimensional case like this axis and this axis makes an angle is theta. Okay, so theta is equals to the length of the geometry to the arc of the geometry, so L is equals to arc theta, all we know. Now we are going to learn solid angle. As an example, we have chosen a watermelon. Okay, the part of the watermelon or a piece of watermelon is taken out from the upper surface like this. This is a total sphere and half of the section is hemispherical shape. Like these types of shape, if I considering these types of shape is removing, or we want to choose in the this amount of area. Okay, if we want to choose in this amount of area, so for for measuring or for quantify this amount of area, the all points regarding this surface area will connect with the center of the axis. Okay, and the all points if I connect with this center of the axis, then we will get a three-dimensional three-dimensional differential angle with respect to this area. Okay, we get three-dimensional differential angle with respect to this area. These types of angle, these types of shapes makes an angle like this point is, this is called the solid angle. Okay, basically it's a three-dimensional angle. And what is the unit of the solid angle? The solid angle basically is defined by omega, like d omega. So the solid angle is defined by d omega equal to dA by r square, dA by r square. Okay, d omega is defined by the dA by r square, or we can write ds by r square. The surface uh, subtended by the solid angle, subtended by the solid angle, okay, at with or with respect to this point or at this point called the solid angle. The surface subtended by the solid angle with respect to this point called the solid angle, and unit is meter square, area meter square by meter square, or we can say steradian. For two-dimensional geometry the unit is radian, and for the three-dimensional geometry it's called steradian. Okay, now this is the basic difference between a two-dimensional and three-dimensional angle. For two-dimensional angle we have considering only the length of the section and corresponding uh, arc of 2 points. So length per arc is defined by two-dimensional case L by R, that means L by R. And solid angle is defined by the surface subtended by the area makes with an angle at a point to the r square is called the solid angle. Now the figure is shown. These types of solid angle is basically created or basically happened. So what is the importance of the solid angle? The question is, what is the importance, why solid angle is needed, why solid angle we learn for analysis, for radiation analysis. We know any object at absolute zero temperature, when it's at absolute zero temperature, any object get emitted radiation, and this radiant energy absorbed by the another surface. Okay, because any object can absorb all temperature or any temperature, any situation, the surface absorbed and the surface emitted also, we know. So from this area, this is the area, this is the normal direction of the area, and this from this surface the radiant energy is emitted. Okay, with an angle, with a certain angle, though we will discuss why this angle after some time. But before, uh, we want to focus here, this surface, this is the normal direction, makes an angle with the normal. From this surface the radiant energy is emitted, and the another surface, this is the another surface, is absorbed this radiant energy. From here radiation emitted from by this surface, radiation, this is a three dimensional surface, this is a three dimensional surface. Obviously the within this surface makes an angle, the surface obviously makes an angle, by the or we can say the surface subtended by an angle at dA called solid angle. So for the solid angle is very important for analysis, this surface which is subtended by the solid angle, and the position of the or the orientation of the surface or area of the surface. Okay, and a radius, it must be a radius. Okay, basically this is a spherical coordinate. So here two theta, and one is the vertical component which is moving from the vertical direction with respect to the vertical direction, and another is the horizontal direction which is moving the horizontally. Okay, it is moving the horizontally. So for better explaining, we know, suppose we are considering a path. Okay, it's a section. Within this section, what is the angle, what will be the angle within this path? Inside the arc, this angle will be, this angle will be 360 degree or 2 pi, because suppose you are standing on this position and a car is moving through this track or passing through these tracks. You as a person seen from these positions, and it will rotate your this initial position. That means your movement is 360 degree. Okay, your movement is 360 degree. But in outside, when your position is outside the arc, this is not your position, the angle by the arc will be 0, because you just move, just tilt some right side and some left side. So ultimate your movement is not defined actually. So the angle is, the outside position is corresponding to your outside position is 0, and the inside your position with respect to this arc is 2 pi or 360 degree. Similar for a sphere, for a sphere. So the angle inside the sphere, or if I want to calculate the inside the sphere, the angle will be 4 pi, because the 4 pi r square by the r square. Okay, the radius 4 pi r square by r square, so r square cancel, it will be 4 pi. Look, this is the black surface. From the black surface the energy is radiated. Okay, and this the axis with corresponding to the normal axis and makes with the projection. Okay, one to the makes with the projection and makes an angle called the phi, and this is the horizontally angle which is considering the through all the surface, and this is the vertical, this is the angle called the azimuth angle, and or create vertically with the respect to the normal. Okay, and here we can we write emitted radiation, the radiation is emitted. Okay, or another surface or whatever it's absorbed, and radiation collectors, radiation is emitted, also radiation collectors, or we can say radiation collectors from the other surfaces. Okay, so solid angle is very important for analysis for heat transfer. Okay, thank you.